Good afternoon, everybody. I hope you've had a great day so far, and we're about ready to get started here on your Algebra 2. Please make sure your notebooks are out and ready, and that you are ready to pay very close attention and understand these new concepts that we're going to be talking about today. Our topic is rational exponents. Now, if you remember the definition of a rational number, it's any number that can be written as a fraction. So basically what we're going to be talking about today is what fraction exponents mean and how they can be used. So let's get started, and we first need to have a definition of what a fraction exponent is in the first place, what a rational exponent is. Okay, so here we go. So our definition is that b to the 1 over n equals the nth root of b. So really the denominator of this fraction is actually the index of the root. These mean exactly the same thing. The fractional exponent is just another way to say it. Now, it works when n is an integer greater than 1. Okay, we've already talked about that. You can't have a root unless this is a 2, 3, 4, 5, 6, on and on and on. So that works the same as in the denominator of the fraction. N has to be an integer greater than 1. We have an exception. You can't have b being smaller than 0. In other words, you can't have an even root of a negative number. So if n is 2, 4, 6, 8, 10, 12, you can't have a negative number under the radical. Okay? If n is 3, 6, 9, 3, 5, 7, 9, if it's odd, you can have a negative root. Okay? So this is our definition of a rational exponent. So we need to take a look a little bit more deeply. When you are trying to evaluate and b is a number, you can use this as a help, as a little bit of a shortcut when you're trying to find your root. Okay, if you take out your calculator, please do that right now. It should be in front of you. So if I want to find the fifth root of 537,824, one way is to go into the math button, do the fifth root like that. However, a quicker way to do it is remember that this 5 is really a fraction exponent. Okay? It's really the fractional exponent 1/5. So this, instead of being written like this, could be written as 537,824 to the 1/5 power. So in your calculator, rather than going down through the math buttons, you can find this by putting in 537,824 and then using your caret and then writing in a fraction 1/5. Okay, it's just an alternate way of finding it. To me, it's a little bit easier to remember because all the keys are showing when you use the fractional exponent. So you can use this as a help. Alright, just a little bit easier on these strange roots. So when we put that in, we find out that the fifth root of 537,824 turns out to be 14. It's a nice whole number. So that's just a very nice little trick that you can use on your calculator based on the definition of a fractional exponent. Alright, so let's take a look at some examples here. Alright, now you can either do these on your calculator if you want to see if it comes out to be a whole number, but if it doesn't, I really want the answer to be in radical form. Okay, this is a 1/4 exponent. So if we're going to rewrite that, okay, you're going to rewrite this. This is really what? It is really a 4th root of 8. Okay, so let's do these as a reveal thing one at a time. Okay, so it's a 4th root of 8, and you would write that like that. Alright? Now let's take a look at the next one. Okay. -8 to the 1/3 power. Okay, -8 to the 1/3 power. You could try that one in your calculator, but before you do that, let's write it in its radical form. Okay, we know it's a radical. This denominator goes right here, that's the index, 3rd root of -8. So what times itself times itself times itself is -8. And once again, you can use your calculator to evaluate. This is almost simplified, except for the fact that this one does come out so that you get an integer. As long as the answer comes out to be an integer, you need to simplify it completely. So this one does come out to be this one does come out to be -2. Alright, so remember the denominator of the fraction. Denominator of the fraction is the index of the root. If it can be simplified, it needs to be simplified. Okay, and finally, hopefully you've had a chance to write that down. I do want you to try. I want you to be anticipating the answer, writing down the things that you know. All right, let's look at another one. The next one is -16 to the 1/4 power. Okay. Now we can try to write that as a root. Okay. We can try to write it as a root. So if we write this as a root, we would be trying to take the 4th root of -16. However, you should be having some red flags go up about now. Okay, I want you to think about why this is a problem. Okay, this is not really the answer. Okay, the answer really is that there is no solution. It's undefined. Okay, I hope that some of you had already had go through your mind. It doesn't work because it's an even power, or it's an even root of a negative. I should say root. Can't have it because it is an even root of a negative number. And you can't have an even root of a negative number. Okay? Alright, so even root, negative number, undefined. Alright, so let's keep moving right along. There's a whole lot of different slides, but each one has just a little bit on it, so let's move on here. Even though we have fractions to deal with now, don't forget your rules about negative exponents. Don't forget your rules about negative exponents. So we're going to take a look at this one. So what happens if you just had a regular negative exponent? Remember, the negative would tell you that this whole expression is not where it belongs in a fraction. This would mean that you would rewrite it as 1 over 4 to the 1/2 so that the exponent turns positive. That's what I mean about don't forget your rules about negative exponents. So you're going to make the exponent positive. Now I am trying to leave enough time for you to write. Obviously I can't adjust my time, but if you have a hard time keeping up, make sure you go to doughtylca.tk and pick up any of the notes that you may not have written completely, but I'm very interested in you paying very close attention right now. Okay. After that, after we have made the exponent positive, then you need to rewrite this in its radical form. This is really 1 over the square root of 4. Remember, the 2 is the index. It happens to be implied here, so it's a square root. And hopefully all of you know what the square root of 4 is. Okay. So this one really was just nothing more than a fancy way of writing a half. Okay, so you go through step by step by step, and when you do that, you find out that these problems are really not as hard as a lot of people think they are. So the negative exponent brings it down. Then you rewrite it in its radical form and then evaluate, and this is the simplest form. Okay, let's take a look at another one. I'm going to leave that one right here. We want to look at 81 to the negative 1/4 power. Alright, I would like you to anticipate what comes next. Okay, same thing as here. So you'll write 1 over 81 to the 1/4 power. Now that you have 1 over 84 to the 1 over 81 to the 1/4 power, hopefully you're recalling that just like here, you would rewrite it in its radical form. That's 1 over the 4th root of 81. So that would equal 1. I'll let you figure that out. Think it through. You can use your calculator to evaluate the 4th root of 81. We find out that it's 3 times 3 times 3 times 3. And that means that it's 1/3. Okay. 1 over the 4th root of 81 does equal 1/3. Okay. Always you're using the negative exponent to put it where it belongs and then evaluate. Now, we didn't end up with any radicals in the denominator, so everything worked out just fine. Okay. Now we're ready to upscale it a little bit. Fractions are not always going to be 1 over a number. Okay. But when you have a fraction that has a numerator and a denominator, and then the denominator is always still going to be the index. The numerator, however, is going to be the power. This can be written in 2 different ways, obviously. Here's our base. Here's our exponent on the inside of the radical. And here's our index. But you could also, if it's more convenient for solving, you can use the root and then take the whole thing to the power. These two, neither one of them is necessarily better until you're faced with a problem and you need to evaluate the solution to that problem. Okay, so there are some conditions as always. First of all, b can't be 0. Okay. M and n have to be integers. N has to be greater than 1. Okay, remember our indices are always greater than 1. And it doesn't work when b is less than 0 and n is even. So these are basically the same rules that we've seen over and over and over again. We saw them for radicals, but now that we have fractions, the fractions just get rewritten into radicals anyway. So the rules really haven't changed. Okay, I'm going to move to the next slide, but it keeps that top stuff, so if you still need to write that, make sure that you get all of these things down. You know, that b is non-zero, m and n are integers, n is greater than 1, and it doesn't work except when b is less than 0 and n is even. Okay. So let's take a look at 32 to the 3/5. There's a couple different ways that you can handle it. Okay, we're going to handle it this way first. It says evaluate, which means that we're looking for an answer for that. Alright, so first thing we're going to do is we're going to rewrite it. So we have actually I want to do this one first. We're going to find the 5th root of 32 and take it to the 3rd power. Now I specifically wanted to show you this one first, and the reason that I wanted to show you this one first is because for this problem it's going to come out more easily than the alternate method. Okay, you'll see why in a minute. The 5th root of 32. 32 is 2 times 2 times 2 times 2 times 2. The 5th root of 32 actually turns out to be just plain 2. So the 5th root of 32 is 2. So this is really 2 to the 3rd power. And 2 times 2 times 2 is 8. Okay. However, you can use the other method. You can put it into this form first. Okay. If we put it into that form, look what happens. We now have the 5th root of 32 cubed. Now in order to do that, we're going to do a little calculator work. This is the same thing as writing this, it's just that the steps to solving will look a little different. 32 to the 3rd power turns out to be 37,268. Don't let a really big number like that scare you. However, when you're copying down so many digits, it's sometimes easier to make a mistake. So you can then take the 5th root of that and get your answer of 8. Now there are probably some of you who are really handy dandy with the calculator who are thinking, wait a minute, couldn't I just put that in all in one step? And the answer is yes. If you wanted to, you take your calculator, you can put in 32 caret parentheses 3-5, 3 divided by 5, and it'll just give you an 8. Okay, I want you to take a minute and do that. And take your calculator. I want you to put in 32, find that caret, parentheses, 3 divided by 5, close the parentheses, and push equals. Okay. Now, I'm just giving it a couple seconds here so that you can do that on your own calculator. Alrighty, we need to move on. All the properties of exponents also apply to fractional exponents. So, when we said for the negatives, you had to watch out for the negative fractions, and you do the same thing with them that you would do with a regular fraction, an integer. You move it down to the bottom. Same thing here. We need to treat these exponents just like you would if they were whole numbers. Now you might remember if you have an x to a power times an x to a power, I hope you remember that you would add the exponents. Okay, so what we need to do is we need to then add the exponents. This is really 2/3 plus 4/3. And when we take a look at that one, 2 and 4 is 6, so this is really x to the 6/3. And x to the 6/3 will reduce to x squared. Okay. This is a whole new example. Whole brand new example down here. Okay, hopefully that one made some good sense. So let's take a look. Now, 1 over c to the 3/5 power. We have a problem. We cannot have a fractional exponent in the denominator of a fraction. We have to solve that problem. Conveniently, the times when we had to move it before and we didn't have a variable here, and we tried to evaluate, the number came down and it came out to actually be evaluated to a whole number or an integer down here, so we didn't have this problem. But now we have to realize that we need to deal with this. You cannot have a root in the denominator. This is really a 5th root. So we need to figure out how much more is needed so that instead of having an exponent of 3/5 here, we will have an exponent of 1. So we need to figure out how much more is needed to make 1. So in order to find out how much more is needed to make 1, all you need to do is subtract. If you take away 3/5 from 1, that gives you 2/5. 2/5 is how much more you need. Okay. Alright, so let me say that one more time. We can't have a fractional exponent. In order to figure out how much more is needed to make the exponent 1, and I'll give you enough time to write that down. We need to figure out how much more is needed to make the exponent 1. So you're going to subtract. and we get 2/5. Now I need to explain to you what you do with the 2/5. You're going to multiply the numerator and denominator by c to the 2/5 power. We figure out this 2/5, then we're going to multiply numerator and denominator by 2/5. That's sort of what we were doing when we had the radicals before. You multiply numerator and denominator by 2/5. Make sure you get a chance to write that down. Multiply numerator and denominator by c to the 2/5 power. Right, so let's see what happens when we actually do that. If I multiply this times c to the 2/5 over c to the 2/5, remember you add the exponents. So we're taking 3/5 and 2/5, that makes 1. So this down here is just c to the 1st power. The numerator, 1 times c to the 2/5 equals c to the 2/5. Okay, here's our 2/5. You add these, you get 1, and here we get c to the 2/5. Now honestly, to make it look just a little bit better, you're going to want to write that into radical form. Okay, so or you can leave it in fraction form, that's fine, as long as you have the fraction in the numerator, not the denominator. So I can add this and say, or the 5th root of c squared over c. So either one of these could be considered the answer. All right. Let's see if we can go just a little bit further. Just a little bit further. I have a whole lot of slides to say each individual little thing, so let's go a little further. Let's look at this. We're going to simplify a to the negative 4/7. Okay, so everybody knows the first step is to, that's right, you put it 1 over a to the 4/7. Okay, so we have a to the negative 4/7 is 1 over a to the 4/7. After that, we can't have a fraction, no fraction exponents in the denominator. So we have to figure out how much more we need to turn this into a 1. So 1 minus 4/7 is 3/7. I need 3/7 more to make this thing work out. So that means that I need to multiply it times a to the 3/7 over a to the 3/7. This is just 1. Remember, just the other day it was pointed out that you can always multiply something by 1. This is just a crazy looking 1. And get the same answer. So really that's all we're doing, multiplying by 1. And when you do this, 4 and 3 is 7, so we have 7/7. This is a to the 1st, and this is a to the 3/7. Okay, to make it look really nice, we can write it in this form. And once again, in order to be finished, no fraction exponents in the denominator, no radicals left in the denominator. Okay, this can't be simplified anymore. So this right here is finished. That one is finished. Alright, let's just do one more for today, and if there is any extra time, you need to begin your homework assignment. You may not have enough information to complete it, but you need to at least make sure that you're up with where we are. So we're going to simplify the 8th root of 16 and the 6th root of 2. Okay. Now, neither the numerator nor the denominator will simplify. The 8th root of 16 all by itself, you're not going to find something, you're not going to find a whole number answer. It's going to be a decimal. The 6th root of 2, once again, won't work. You're going to find a decimal. So you need to begin to work through the problem so that you can simplify it as much as possible. Now, unfortunately, with these, your calculator can help you, but if you try and put it in, it's not going to give you the answer in radical form. Okay, so let's see what we can do with this. This is what I mean by like bases. This is the 8th root of 2 to the 4th power. So it may seem right off the bat as if you're taking a little bit of a step backwards. This one, rewrite it with its exponent. If you factored out 16, you'd have 2 times 2 times 2 times 2. It's 2 to the 4th power. And this one's just a 2. So these like bases are going to help us. We can't just bring them under one radical umbrella. That doesn't work. But the 2's are definitely going to help us, because we can rewrite these radicals as fraction exponents, and then it's going to make a whole lot more sense. Okay, this is 2 to the 4/8, and this is 2 to the 1/6 power. Now what you should remember is that whenever you have like bases and you have exponents, you can actually subtract the exponents. When you subtract the exponents, you're going to simplify. Now the 4/8 is bigger than 1/6, or 1/2 is bigger than 1/6. So the actual base, which is 2, will end up being in the numerator. The denominator will turn into a 1, which means it disappears. So here's our 2 to the 4/8 minus 1/6 power. We then simplify that. 4/8 minus 1/6 is actually 1/3. And you can use your calculator to help you with that. Or we could write it as the cube root of 2. Okay, so this one is completely simplified. We took care of the indices, so the indices came down to be the smallest that the index could possibly be. There is no radical in the denominator, and so our problem is done. Okay, now as I said, that's where we're going to stop for the day as far as notes, and your job right now is to work on the homework assignment until the end of the period, and have a blessed evening and be ready to learn more things.